Good day, ladies and gentlemen. This is Sarel van Grennen, aka Mr. VG, and welcome to our first in-depth look at grade 9 triangle geometry, where we're specifically going to look at the concept of congruency. Now, congruency is a very important concept, but actually after grade 9, you'll see it only once or twice more in grade 10, maybe a bit in grade 11 and 12, but very, very, very seldom. But what is congruency? Well, congruency actually doesn't have anything to do specifically with triangles, although we work in triangles, but it doesn't specifically have anything to do with triangles. It is when two shapes are equal in both size, but also in shape. So in other words, it's two shapes that are not just looking the same, but basically are the same. The one is just flipped around, moved, or something like that. But this could be two rectangles that are the same shape, or two triangles that are the same shape. It could be either, we don't really know. But when we look specifically at congruency, we are going to look at congruency in triangles because that's easy to prove. So again, it's not that it can't be done in any other shapes, it's just that it's not so easy to prove in other shapes. When we talk about congruency in triangles, the first way we can prove congruency in triangles is when we've got three pairs of sides that are the same. Now, this is not asked often because there's nothing much difficult about it. We kind of have to give you everything. But we love to look at RHS because you need a right angle, a hypotenuse, and another side. Not asked often, but still asked sometimes. But the two that we love to ask most in the exam is SAS. Now, I always think about some of those girls in the class, the sassy girls. SAS. Two legs and an angle in between. The angle has to be in between. But also we love when we are given two pairs of angles and then the side that is opposite it. What is missing by mine? I'm missing my one pair of sides there at the top. My one pair of angles. Man, this is fun. When we look at this, that's the only four ways we have. It's the four conditions we have, ladies and gents, to prove triangles congruent. This is the bare minimum we need. Let's look at a few examples. I'm going to look at two examples with you. So in this shape, we are given that DE is perpendicular to BC, that BE is equal to CE, and the question is, prove with reason that triangle BED is congruent to triangle CED. I see that I forgot to put my little triangle in there. My apologies. Now, when we look at this, there's a recipe that I want you to follow. And please follow this. You have to specify which triangles you work in. And then, once you've specified the triangles, I can tell you there's going to be a number 1, a number 2, a number 3. Think about it. It's SSS, RHS, AAS, SAS. There's always 3 pairs of things that we need to prove equal. So I'm always going to have a 1, 2, and 3. I love to start off with what was given. First of all, given is that CE is the same as BE. It's given. Now, what else has been given? Well, they told me there's a perpendicular line there. So that means that D1 is equal to D2 because they're both 90 degrees, and that's given. Now, thirdly, you always remember to look for something that is common between the two triangles. So if I go and highlight my two triangles like that, isn't there some line or angle that is basically highlighted twice? Well, yes. The one that's highlighted twice is DE, and therefore DE is common, meaning DE is the same in the one triangle as it is in the other triangle. And therefore, if we just sketch them a bit separate, I'm going to separate my sketch. I'm going to see that I've got a right angle, a pair of 90 degrees that are equal. The hypotenuses are equal. That's the side opposite the 90. And then a pair of sides that are equal. And therefore, triangle BED is congruent to triangle CED because of RHS. Very, very important. Easy example, but we love this example in a test because of that common side. So don't forget to look for the common side. The next example has got a bit more work in it. I advise you to hit the pause button, try it yourself, and then come back to the video. In this accompanying sketch, first of all, AB is parallel to DE. I'm going to look at that in a very short while. But also BC is equal to CD. So, prove that triangle ABC is congruent to triangle EDC. So I'm going to start with my recipe. In triangle ABC and triangle EDC, 1, 2, 3. Where do I start? I start by what's given to me. And what has been given to me? That BC is equal to CD. Now, once I've got that, I'm going to go back to my first bit of information that was given. That AB is parallel to CD. So I'm going to look either at F, U, or N. But there is no F if I look at this side being parallel to that side. There is no F because there's no extension there. There is no U, so I'm going to look at N. What does alternate angles say? Alternate angles say that angle A is the same as angle E, angle B is the same as angle D. So I'm going to pick a pair. So angle B is equal to angle D because of alternate angles. Please don't forget to write your parallel lines. Please, 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 please. Now, thirdly, I'm actually going to look at C1 and C2. Why? I'm less. It doesn't matter. But I'm going to look at angle C1 and equal to angle C2. Why is that? Because they are vertically opposite angles. I mustn't leave my grade 8 knowledge in grade 8. I must bring it with. Now, what do I have? I've got two pairs of angles and a side in between, kind of squashed between the angles. So in other words, I'm going to say, therefore, triangle ABC is congruent to triangle EDC because of angle, angle, side. Wow, awesome stuff. I encourage you, go and practice, 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 because practice makes perfect. Ladies and gents, this is Sarel van Grinnen, aka Mr. VG, signing out. Have a gorgeous, amazing, wonderful rest of your day. Keep yourself safe, keep yourself warm, and go and be the best person you can be today. Cheers.